So this is part one of a video to show the solutions to this additional practice for the comprehensive exam. And I'm just going to do basically one page per video so that it's easy to keep it straight so you can jump in where you want to. So this is part one. We're trying to just make sure we understand for quadratic functions how we find the vertex, the intercepts, and the range. There are lots of other terms and things that you can talk about with these things, but this will at least get us some practice. Remember, there's a practice sheet on this that has 16 different problems in different forms with solutions to the first 4 that are posted by video, and answers to the rest are given on the worksheet. So if you do want to see additional problems along these lines, there's a rich resource in that. Okay, so the vertex, this depends on the form that the thing is written in. This is written in the ax squared plus bx plus c form. So we know that when our quadratic is written as ax squared plus bx plus c, the x-coordinate of the vertex is given by minus b over 2a, which in this case is negative 3 over 2. Because b is 3 and a is 1 in this problem. The y-coordinate is going to be what we get by plugging in negative 3/2 for x in the formula. Remember, the formula for our function is essentially a formula for the y-coordinates. So if we need a y-coordinate, we always plug in our known value of x. That will be, I did it somewhere, but where did I put that? Yeah, that'll be minus 169 over 4, of all things. And so my vertex coordinates are negative 3/2, negative 169 over 4. From the vertex, once we know that, we can use that to figure out the range. Notice that this parabola, the a here is greater than 0, and so our parabola looks like this. It's an upward concave parabola, and so that means that the range, remember the range are just the y-coordinates that you'll ever see, the range is going to be from some y-coordinate and then all the y-coordinates above that. And so the bottom y-coordinate, the first y-coordinate that you would come to, is the y-coordinate of the vertex. So the range is going to be negative 169 over 4, including that. Negative 169 over 4 really does happen at the vertex, and then to infinity. So you can see any y-coordinate as a point somewhere on this parabola, as long as the y-coordinate is greater than or equal to negative 169 over 4. So in other words, the vertex gives us the very bottommost y-coordinate. And so that's part C. So that's A and C. To get the intercepts, we know, I'll just move this over. We know that to find the y-intercept is just a matter of calculating f of 0. So here f of 0 is negative 40. So that's easy. So the point 0, negative 40 is the y-intercept. To find the x-intercept, I have to solve the equation x squared plus 3x minus 40 equals 0, because remember, x squared plus 3x minus 40 is a formula for y-coordinates, and so the x-intercept occurs when the y-coordinate is equal to 0. So we've literally written down the formula for the y-coordinate is equal to 0, and we have to solve for x. This thing does factor, so I'll just skip to the answer. Once you factor this, you'll find that x can be 5 or x can be negative 8. Certainly 5 is easy to check. Put 5 in for x and you'll see that makes the equation true. So don't forget, check answers if they're easy to check. That will head off a lot of the common errors, but that's how we get all of those guys. Now in the second problem, This is not written in ax squared plus bx plus c form. This is written in our vertex form. And so this actually makes life easier to find the vertex, because the vertex is going to be at 5, 8. The 5 here comes from thinking what makes this part 0. So when I have a quadratic written in this form, the vertex is going to be the value of x that makes this squared part equal to 0. So obviously x equals 5 makes that 0. And if you put 5 in for x, then you'll have minus 2 times 0 plus 8, so you get a y equals 8. So this form is supposed to highlight the vertex, and so we should be able to read the vertex off directly from that. We can see that the number in front of the x squared term, the a, if we did multiply it out into ax squared plus bx plus c form, I don't have to do that to see that the a is going to be negative. The a is going to be negative 2. So because that's a negative number, this parabola has this shape. So it's concave down, which means that the range is going to be all the y-coordinates from the highest y-coordinate, which is at 8, down to minus infinity. So we would write it this way, minus infinity to 8, including 8. So again, the y-coordinate of the vertex is the key part to understanding the range of the function. I just have to know the y-coordinate of the vertex, and I need to know which way the parabola is going, and I can answer the question about the range. Intercepts, again, the y-intercept is always easy to find because that's just a matter of making the x equal to 0, and so this will be negative 2 times negative 5 squared plus 8, and so that's negative 50 plus 8 is negative 42, I believe. Checking my calculator. Negative 42, and so therefore the y-intercept is 0, negative 42. To find the to find the x-intercepts, again, I need to set the formula equal to 0. Again, my motivation there is that I know I want the y-coordinate to be 0, and the formula for the function is a formula for y-coordinates. So I want that to be true. In this form, we could do FOIL and try to deal with all the minus signs, which is actually harder. But we talked about this form as a we have an equation that's written in this form, an easier solution strategy, and that is just to isolate the square part. So the x minus 5 squared. If I subtract it from both sides by negative 2, then this equation will be x minus 5 squared equals 4. And so when the only way I can have a square equal to 4, well, there's two ways. The thing that's being squared could be 2, and then the square of that would be 4. Or the thing that's being squared could be negative 2. So when we have something written in this form, where we have a perfect square equal a number, then the thing that's being squared is plus or minus the square root of that number. And since this square root is a nice number, it makes it even nicer to do. But even if this had been a 3 here, I would still say x minus 5 is the square root of 3, or x minus 5 is negative the square root of 3. So no matter what number it is here, I can always go to this next step. And so that means that I know that x will be 7, or x will be 3. And so my two x-intercepts are 7, 0, and 3, 0. For the third problem, this is just like the first one, so I won't actually go through the steps. It looks just like number 1. It is true in this case, though, that there's only one x-intercept, so that is certainly a possibility. So I'll encourage you to go through it and try it, but what the graph of this is going to look like is something like this. So this is a case where the graph just comes down and kisses the x-axis. So you have just one x-intercept, just one y-intercept, and the rest of it follows the same way. But it'll fall out just like number 1, so I won't do that one separately. Number 4 does show us a different form. So again, finding the vertex first is not always a great idea, because this is not written in a form that highlights the vertex. This form highlights the x-intercepts. So let me start with that. I'll start with the intercepts here. So f of 0, for example, to find the y-intercept, that'll be 3 times 5, 15. So very easy to plug 0 in for x. And then to find the x-intercepts, remember that I'm setting the formula. The formula for the function is the formula for y-coordinates, and I want the y-coordinate to be equal to 0. And so because this is factored, that means that one of the two factors has to be 0, which means that x is either 3/2 or x is negative 5/2. And so my intercepts in this case, let's give myself some room up here. My intercepts in this case, the y-intercept is 0, 15, and the x-intercepts are 3/2, 0, and negative 5/2, 0. So the reason that we find the intercepts first is because the vertex then can be found without having to multiply this thing out because of symmetry. The vertex should occur halfway between these two x-coordinates. So the x-coordinate of the vertex is going to be halfway between 3/2 and negative 5/2. The way I get a number that's halfway between two numbers is just take the average. So if I add 3/2 and negative 5/2 and divide that by 2, that's the average of those two numbers. So in the numerator, I have 3/2 plus negative 5/2 is negative 1 divided by 2. So negative 1/2 is halfway between x equals 3/2 and x equals negative 5/2. Now the y-coordinate, I'm going to find by just plugging negative 1/2 in for the x-coordinates. And in this case, that doesn't end up being a bad number at all. You get 4 times 4, 16. If you plug in negative 5/2 directly into this equation, just put x equals negative 1/2 in here, and that's what you'll get. So that's the vertex. These are my intercepts up here, and the only thing I need left is the range. So I need to know which way this parabola is facing. So for this, I do need to at least think about what this is going to look like multiplied out. I don't have to really do it. I know that this times this, right, in FOIL, is going to be negative 4x squared. So that's going to be a negative number in front of the x squared term, which tells me that the parabola has this shape. So it's a concave down parabola. And so therefore, 16, the vertex, must be the highest value of the y-coordinate. So it's the highest y-coordinate on the graph, which means that my range should be minus infinity up to 16. So I've got my vertex, I've got my range, and I've got my intercepts. Okay, last problem. This is one, again, written in ax squared plus bx plus c form, and so my vertex x-coordinate is minus b over 2a, which is 8 over 4, which is 2. And my vertex y-coordinate is just f of 2. And if you plug in 2 for x, you get negative 9. So the vertex of this parabola is at 2, negative 9. The y-intercept is easy. That's plugging in 0 for x, so I won't do that here. The x-intercept here is, again, going to be where the formula for my y-coordinates is equal to 0. I want my y-coordinate to be 0. And the reason I wanted to do this one specially is because this uses the quadratic formula. So you can try factoring that, but it really has no chance. If you look at just the first thing you have to do is find two numbers that multiply together to be 2 that add up to 8 or something, and that's hard to do. So anyway, so the quadratic formula says that x should be negative b, so that's 8. Right? The a here is 1. A is 2. B is negative 8, and c is negative 1. So 8 plus or minus square root b squared is 64 minus 4ac, so that's 4 times 2 times negative 1. So be careful with the negatives here. So I have 4 times 2 times negative 1, that's negative 8. 64 minus negative 8 is 64 plus 8. And that's all divided by 2a, which is 4 in this case. So I have 8 plus or minus the square root of 72, all divided by 4. So those are the two x-coordinates of the of the x-intercepts. And you can rewrite square root of 72, because 72 is 36 times 2. So 72 does have a perfect square as a factor, so you can reduce that, and I think the way I wrote it on the answers has the reduced form. But on an exam, I would certainly be happy with that as your answer. Remember, if I'm describing this as a point, I would want to say 8 plus square root of 72 over 4, comma 0, and 8 minus square root of 72 over 4, comma 0.